100 meters beneath the Franco-Swiss border sits a machine spanning 27 kilometers in circumference. This is the world's most powerful particle accelerator. Looking down this tunnel at these blue superconducting magnets, you're seeing the veins of the Large Hadron Collider. It was built to accelerate protons to over 99.9%. The speed of light, creating head-on collisions that recreate the exact physical conditions present trillions of a second after the Big Bang. This diagram maps the standard model of physics, our best instruction manual for how subatomic particles interact. But for decades, it had a glaring gap. Physicists could catalog the universe's ingredients, but they could not mathematically explain how any of those particles acquired mass. Solving that mystery required firing particles with extreme levels of kinetic energy, testing physical limits that had existed only in theory. This venture into the unknown terrified a vocal segment of the public. To figure out exactly how the universe was assembled, researchers realized they had to build a machine capable of smashing its most basic pieces apart. As the 2008 launch date approached, the sheer scale of that energy output generated global panic. The tension between the pursuit of scientific progress and the fear of an engineered apocalypse reached a boiling point. The fear reached the highest levels of the legal system. In Sancho VU, Department of Energy plaintiffs filed federal lawsuits attempting to halt the collider's operation, alleging that the government hadn't properly assessed the potential for planetary disaster. The filings outlined specific existential scenarios. Critics argued the collider's violent proton crashes would spawn microscopic black holes that would sink into the Earth's core, accrete matter, and eventually swallow the planet. Then there was the strange lit disaster theory. This was the fear that collisions might forge a highly stable, infectious state of matter that would rapidly convert everything on Earth into a super dense ball of cosmic goo. The lawsuits brought a difficult philosophical debate into the public eye. How much existential risk should society accept in exchange for understanding reality? On September 10, 2008, scientists powered up the magnets. Two glowing beams of protons raced in opposite directions, accelerating until they crossed paths at a record. Breaking 7 tera-electron volts inside the CERN control center, operators calmly monitored the incoming data. No black holes formed. No strange lips consumed the floorboards. The Earth kept spinning. So how are thousands of physicists so absolutely certain they wouldn't accidentally unravel reality? The answer is documented. In the LHC Safety Assessment Group report, the authors note a crucial fact. Nature has been conducting these exact high-energy collisions for billions of years. Our planet is constantly bombarded by high-energy cosmic rays. The universe is a violently energetic arena, and it routinely absorbs impacts far greater than anything humanity could ever engineer. This graphic illustrates just how vast that safety record is. While we worried about our single subterranean machine, nature had already safely conducted the equivalent of 10 to the 31st power LHC experiments on Earth alone. As the graphic shifts, you can see what actually happens during these high-speed collisions. The immense kinetic energy temporarily transforms into highly unstable subatomic particles. They don't linger and they don't grow. They decay back into normal matter almost instantly. That's why massive gold panel structures like the Atlas detector are necessary. They capture the brief, microscopic flight paths of those particles before they vanish. This machine serves as a massive sensory organ, allowing us to record the invisible subatomic processes that have shaped the cosmos since the beginning. 4 years later, on July 4th, 2012, that sensory organ caught something historic at a crowded press conference, CERN. Scientists confirmed they had spotted a spike in their data, a particle weighing 125 giga-electron volts. This animation represents the Higgs field, the exact mechanism physicists have been looking for. It acts a bit like cosmic molasses as particles move through it. Some pass freely at the speed of light, while others drag, slow down, and gain mass. By slowing those particles down, the field allows them to clump together. Without it, every electron and quark would zip through space at light speed, making the formation of atoms, stars, and human beings impossible. With the discovery of the Higgs boson, we finally identified a mechanical process that lets the physical universe hold itself together. The machine's work didn't end with the HIDS. Today, the collider continues to run, probing past current theories to hunt for the elusive source of dark matter. Looking back at the lawsuits and the doomsday headlines, it's clear that the path to discovery is often lined with anxiety. Stepping into the unknown is the price of admission for uncovering realities. True architecture, because the deeper we go into reality, the stranger it becomes. Human curiosity must always be brave enough to look past the fear of the dark.